Hey everyone, this is Professor Dima. Today we're going to be going over our next week's lab over Zoom. Uh, Leave some comments if you have any questions, or unmute your mic. I can hear you guys too. Is the audio okay? Okay, cool. So next week's experiment is going to be the acid hydrolysis of amino acids for analysis on HPLC. So to begin with, we have our amino acid, the R groups, differentiate it, but the idea behind acid hydrolysis is to break up the individual amino acids so we can analyze them. And this is good because it allows us to, or this test exactly, allows us to recover them, sorry about that, which is one run for at least the major amino acids. So basically what acid hydrolysis does is it adds water to all the covalent peptide bonds, and that'll end up looking like, the final product over there, but there'll be multiple of them. There are a lot of amino acids on our samples, our unknowns that I'm going to be giving you guys. Or, well, you're going to pick them out, but when you record the number, I'm going to know what samples levels will be expected, and you guys will be graded according to how close you are to the actual results. So try to do this one with as much caution as possible. I'll make sure to give you guys tips on where you will lose accuracy. But to go over this, what we have here is our amino acid in our sample, and the addition of six normal HCl and 2 parts water. That's what's going to be adding the water to the covalent peptide bonds. Therefore cutting it, cleaving it, basically hydrolyzing it, acid hydrolysis. And then we can take that and put it on our instrument, and then I'll show you guys how to evaluate your chromatogram when I get through the rest of this. But so that's the overall for this. I'm going to go over what our lab will look like the day one. This is a 2-day process, so we're going to be good. Let me just clear this board quick. All right. So what we start off with is our sample. You guys are going to have your unknown. I want you guys to take your unknown. Yeah, I'm going to make that question mark. Can you guys see that? Okay, cool. And you're going to weigh that out onto our balance. The one, like this. You're going to weigh up in a weigh boat. Or, no, I'm not going to make you weigh up in a weigh boat. I'll show you guys how to weigh up it into a combustion tube, because this is where they're going to be combusted in our oven. So usually we use like a Erlenmeyer flask because these are an odd shape. And we stuff it with tissues. Then we put that tube in, and then it'll be able to sit in there. You can tear the scale, and whatever value you get, it needs to be around 0.5 grams. It doesn't have to be exactly that. I'll tell you why in a little bit, but make sure you record exactly what the scale says. Make sure you tear it properly. Make sure you weigh out your sample properly. If you have any issues with the scale, let me know. Okay. So you're going to weigh up 0.5 grams. Now then, you're going to take that, and it's going to be in a combustion tube, right? It's going to look like this, and then you're going to have your 0.5 gram of sample in your combustion tube. You're going to label it with your name. It's going to the Dima, and then today's date. I'm just going to put, today's date. Label everything that you might forget. So if you're putting sample in something, label it. If you're putting a liquid into a beaker, make sure that beaker is labeled. Make sure everything is labeled so that if you go away or you even just forget, you'll know what exactly it is in there. You really don't want to have to waste reagent or reweigh something because you forgot to or chose not to label one of your pieces of glassware. It doesn't take that much longer. You guys all have your little Sharpies. I've given them to you, so just make sure you label it. And if you don't, then you're not going to know what your sample is when it comes out of the oven. You won't be able to do the rest of the experiment. So let's begin. You're going to take your combustion tube and we're going to add into it 5 mils of our internal standard. We're going to do this first because when you add in an internal standard, you want to have it in as early as possible to ensure that it gets in there and that it follows the experiment much more better. So what's going to happen in this experiment is the hydrolysis of the amino acids. You wouldn't want to put it in on the day 2 when we're going to go and dilute it because there's no point in that. The most I guess harmful or destructive part of this test is going to be when it gets into the pardon me, oven, and then we it's going to combust in there, hydrolyze. That's when you can lose sample. And that'll happen to not even your guys' fault, just like the oven might do it. If you know how much internal standard you put in, and then we still run the test and we see what happened on there, we can account for that. If everyone else had the same problem with their internal standard being low or high, it'll most likely be low, probably won't be high. If that happened. If it's high, you put in too much. If it's low, you probably did it wrong. If everyone's low, something went wrong with the oven, but make sure you're doing this step properly. So that's just I hate to get off that tangent, but yes, that is why we add in an internal standard before on the day 1, not day 2, because you want to account for loss as early as possible. So what we're going to take is you're going to take a beaker, and since we only need 5 mils, you guys won't need to use more than just pouring 10 or 20. The internal standard's easy to make. Just don't put in 50 and then dump it. You guys can share. No, I don't want you guys to share. I want you guys to all get in the habit of labeling your beakers and not running around. There's going to be a bottle of internal standard. You guys are going to take turns pouring it into your beaker, okay? So you're going to label this with the Norleucine. That's what it is, the Norleucine internal standard. L-leucine is also going to be found in your amino acid, but we're going to use the Nor part of that, which is going to be our amount that we know we added in. And so using a glass pipette, this is a great glass pipette, you're going to put in 5 mils of this internal standard, and you're going to put it into this combustion tube. I'll give you guys all a little rack to set these in. Since you're only doing one of these, you're just gonna you can hold the glass pipette, but also there's this nice little lip that you can rest your glass pipette in. I can show you guys that. You won't need to worry about that, but if you're doing a lot more of these for production, working in a nutritional lab that might have this test getting ran all the time, you're gonna want to look for shortcuts like this. Not really shortcuts, but things to make your job more efficient. I'm getting off topic. We'll get back to this. So you're going to add in 5 mils of the internal standard, okay? Now, you guys all have vortexes in your hoods. So what you're going to be doing is vortexing your sample each time you add in a liquid. So you're going to be adding in, your internal standard, and I'm going to draw the vortex right here. Very poor vortex, anyways. So 5 mil internal standard. You're going to add in 5 mil of 12 normal HCl. Then you're going to add in 5 mil water, GI water. So the reason why we add in 5 mil of water and 5 mil of 12 normal HCl is to get it to 6 normal HCl. Got it? Cool. So You add in this internal standard, you vortex it. You add in the acid, you vortex it. You add in the water, you vortex it. All right? I want to make that clear, guys, because the things that will make you lose points on this assignment is not doing this correctly. So make sure you're vortexing it correctly. What you're going to be using for the acid is just a pump. You're just going to go up and then down. It's really not going to be that difficult. Water, same thing. The internal standard is the most important, okay? Use a clean pipette, get it right to the meniscus, and just let it go in. Don't try to blow it out. These pipettes aren't like that. And don't try to get the last drop. You won't. They're designed, calibrated, and made to specification to not need you to get that last drop. That's going to stay in there. Okay. Now we're going to move on to the vacuuming stage because we want to try to eliminate the air that's going to be in our combustion tubes. Now, some of the amino acids can't actually be they can't be quantified by acid hydrolysis. The acid is, it'll degrade them. L-tryptophan is one of them. We have to use a very specific alkaline hydrolysis, or I think it's a lithium hydrolysis. Can't remember. To get some of them, and then there's some other ones that need, the alkaline process, where instead of using an acid, you use a cold base, and then you freeze it for the day, and then you do the oven part. So that one's a 3-day. This one's gonna be 2 days. So, apologies. So you're gonna have your tube. You're gonna have, your sample in liquid. You guys can see that, right? Okay, cool. And then what you're gonna do is you're going to, and this is gonna be from the hood. It's gonna be like, you should all have a vacuum in your hood. You guys have used these before. So you're going to take that and you're going to put a vacuum pump on it for about, 30 seconds to a minute. Doesn't matter if you go over. Okay. For this one, 30 seconds is fine. And then after that, you're going to purge it with not hydrogen, nitrogen gas. And that's also going to help, prevent degradation or over-degradation by oxygen in the hydrolysis reaction. So then what you're going to do is, after you, vacuum degassed it and put nitrogen in it, I'm going to have a rack at the front of the table. Make sure your thing is still labeled, okay? I'm going to have a bigger rack here. There's about, 24 of you guys. This rack will fit all of your guys' perfectly. Then you're just going to put yours up there. Doesn't matter where. Just put it there. Sometimes the marker labels can go, they can fade away on here. So what I like to do is, use the, Sharpie and then write out like as much information that you possibly can that you will be able to recognize that it's your sample. So I like to put, my name and date, what I'm testing. I might, draw on it a little bit, like literally just so when it comes out of the oven, there'll still be parts of it that like you'll be like, yep, that one's mine, even if like maybe half of your name's like gone for some reason. They can, on the glass, it can get rubbed off. So if you, aren't sure that you grabbed yours, be very careful about that, okay? So that's going to be the end of day 1. What for you guys? What I'm going to do is, after you guys put all yours in the rack, I'm going to put them into an oven. Yeah, OV, I think 12 is set up for this one. I forgot what temperature it is, but it's going to help assist with the hydrolysis, or it's required for the hydrolysis, really. And that'll be there for, it'll be done for about 24 hours. since you guys are doing this Monday and Wednesday, I'll grab those ones. I was gonna have you guys come in to grab them around your lab time on Tuesdays, but of course that's not gonna work out. So you guys are not gonna have to worry about taking them out. I'm gonna look over them and see if any of the labels got messed up, and I'll try to like organize them myself. But yeah, they should be good for the next day when you guys come in. The results might be a little bit lower because of the fact that it's, they might sit for 24 hours, but they'll be fine as long as they're kept in their main thing and they're not diluted before. So day 2 will be this will be the dilution step. So I mean, technically day 3 for you guys, but it's day 2. This is a 2-day test. So you guys are gonna come in. You're gonna find your thing, your combustion tube, and it's gonna be, sorry about that. It's gonna be like a dark black brownish, kind of maybe a little bit orangish will be in there, color. Okay, you might have maybe yours dried out in there. We'll have to see like what happens. You'll still test it as accordingly, but if there's like a low value, I'll try to see like what might have happened. I don't want to, lower your guys' grades because of something that happened with the oven. So make sure you put the tube on tight. I'll probably end up making sure that they're all good too. So if your sample does end up drying out, it won't be that big of a deal, but you're still going to do it the same way as this. So you're going to set up a volumetric flask. It's going to be, oh God, is that, it doesn't look that bad. Okay. It's going to be a 250. I don't really want to, sorry about that, guys. Okay. You're going to take this, and then you're going to put in a funnel for fun. And you're going to make sure that you have filter paper in it. You're going to take this, make sure that you vortex it before, make sure you vortex it before doing this part, okay? And then you're going to take this and you're going to wash it into the filter. You're going to clean out your combustion tube with water. Make sure that like all of the stuff is in there. Like all of whatever's in your combustion tube, like squirt it with like a little bit of water, shake it up a little bit, pour it in. Do that multiple times to make sure that you get all the aminos into this. You probably won't end up overfilling it by doing that, but this next one you might. So this one's going to be a little bit more careful on. So you're going to have the black or brown gunk that's going to be in this filter, and you're going to be filtering that down like coffee. You don't want to get any of the coffee grounds in your coffee. You don't want to drink that, right? And the LC doesn't want to drink that either. So you guys are going to make sure that the LC doesn't drink coffee grounds. So make sure you have the filter here. Make sure not to get aminos in here. If you do, it's not a huge deal, but again, we're going to try not to. And you're gonna rinse it down at least 3 times. At least 3 times, okay? With your squirt bottle, just go around it once. And wait, don't like fill it all the way up, because what you're trying to do is get, you make sure it all goes through the filter. You're not trying to get it in the volumetric glass, but you're trying to get it into solution properly. So do that around 3 times. It's still going to be there when you're done on the 3rd one, but when you fill this up with water, it's going to be a nice, cool orange color, and then you're going to be like, yes, you got amino there. All right. So then, once you dilute it, we're going to try, because we don't want to overload the columns, I'll have to give you guys the exact concentration that we're diluting to, but once you get it down into the volumetric flask, you guys know how to, dilute the volume. You're going to have your meniscus, go low and slow. if you if you have your sample here, you can probably pour in some water, but once it gets, up to the neck, that's when you need to stop, like, crouch down and slowly squeeze the bottle in there, up until this. Then you're going to cap it and invert it like so. Or I think you don't want to do it with your wrist because this is 250 milliliters, and over time that can kind of hurt it. So what you're going to do instead is sort of like a shaking motion like this. Right, like this? No. Like this. Or is it? No, that's what yours. I think it's this. Don't get it on your face. You won't. Right? Okay, so once you invert it, what we're going to do is we're going to take 2 mils of this and put it into a plastic, disposable tube. You're going to put 8 mils in this of water. Okay, so you're going to put in 8 mils of water first, and then 2 mil of your sample. And we're going to be doing that with, a pipette. You guys, disposable tips and stuff too. You guys have used these before. If you need help, depress it first slightly. Don't go to the last click. You'll go to the last click on the second try. So pull it down, and go into the solution. Lightly lift up, and then when you carry it, put it in there. Push, then push finally. Then eject it into the trash. Okay. Then you're gonna vortex this. Remember, vortexing is, you gotta make sure that your solution is homogeneous, and the better you vortex, the better your results will be. You gotta make sure you're consistent with your quality. And then what we'll do is we're gonna go and vial this up. So you're gonna have a filter vial. Its cap is gonna look like this, and the vial itself is gonna look like this. You're going to put your name and group number on this, because I'm going to be loading this with other classes samples too. So put your name, group, whatever. You guys know which group you are. And then you can either use your fingers, or better yet, we have a metal crimper closer thing that will do it for you. Make sure you go slowly so it doesn't like spill out all the sample. And make sure when you put your sample in there, you don't go over the fill line. There will be a fill line there. You guys will notice it. And then once you guys have your vial done, there's going to be a tray up front. And then you're just going to put that vial in the tray, and then sign your name that you put your vial in there. You won't have to worry about the spot. I'm going to load these on in, the order that you guys put yours in. So try to use, put your vial in the tray, where, one before the other. I don't put it in like a random spot, but, I'm still going to go through them to make sure that they're going to be in the right spot on the instrument. And put your weight down. Put your weight down on that paper. When you're writing this in your lab notebook, put your weight down on that paper, okay? It'll be very helpful, because I'm going to have to enter those all in. And it's going to be a lot of numbers, but don't worry. Now then, that should be everything. If there's any questions, just let me know. Rewatch this video, and I'll see you guys on Monday.